A weight is attached with a trolley with the help of this string, and this trolley can accelerate on the frictionless table. So this is a direction of acceleration. So in this question, we have to find out the value of this weight. So this question is about the forces. So first of all, we will draw the forces exerted on every body, and then we will also make the free body diagram. So this must be the force of tension, which is pulling the trolley to the right side. And don't you think that the force of tension is always same on the both ends of a string? So same amount of force of tension is also exerted here, but that is upward, whereas the direction of the weight, force of gravity, must be downward because it is accelerating downward. So this is a direction of acceleration of weight. So let's draw now free body diagram. So if we represent this dot as a trolley, so we see that the one force is exerted to the right side, that is the force of tension, whereas the two forces which are exerted on the trolley are balancing each other. And you know that this force is exerted by the table on trolley, and this is a weight of the trolley, means the force of gravity. These two are balancing each other. So now this can help us to write equation for the trolley, because this is the only unbalanced force. So if we apply the Newton's second law, then according to that, the force of tension, which is our resultant force, must be equals to the mass of trolley, capital M A. It's written here capital M. So this must be our first equation. Now we will draw the free body diagram of the weight. So students, you know that there is a no force exerted on weight along x-axis. So the one force that is exerted upward is the force of tension, same, but the force that is exerted downward is none other than the weight, and that's why it must be greater than force of tension. So what is the resultant force in this case? That must be force of tension minus weight, minus because this force is downward. Okay, it will produce the negative acceleration, right? Why negative? Once again, you remember I told you that it's a downward, so that's why I must write negative a. Whereas what is the mass of this weight? So the mass of this weight, whatever that is, it we can write it like this, W over G. So I'm going to write here W over G. So this is the equation according to Newton's second law. We can adjust it. I mean, we can take common negative one. We can also write it W minus force of tension is equals to positive A into W over G. So I have written the same equation again. So force of tension is equals to capital MA. We can substitute here. So W minus MA is equals to A into W over G. So what we have to find out, we have to find out the W, so we can gather the same variables on one side. So it must be W minus A, or you can also write W into A over G. All right. Whereas we can take this negative MA to the other side, so then it will become positive MA, capital MA. That's the mass of trolley times acceleration. We can take W out of this and we will get 1 minus A over G inside the bracket and is equals to MA. All right, so in this question we want to find out W, so we have to move the other things on the other side of the equation. So can we write this one as G over G, and later on this will become G minus A over G is equals to MA. If you take G from the denominator to the other side, or in other words multiplying G on the both sides, so we will get is equals to capital MAG, and finally the weight, its expression is MAG over G minus A, which means that the right answer is option A.